All right, guys, so today we're going to be looking at notes for 7.5 parts of similar triangles. So to start off the notes, we are saying that if we have two triangles that are similar, then the lengths of the corresponding altitudes, angle bisectors, and medians are proportional to the lengths of the corresponding sides of the triangle. Okay, and we'll kind of see what that looks like here with altitudes to start off. So really what we're saying here is that if these two triangles are similar, okay, then the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So that this makes a little bit more sense, we're going to kind of rely on our highlighters again. What we're saying here essentially is that, hey, this altitude, okay, and I know this is an altitude because it starts from a vertex and goes to the opposite side, and altitudes create a 90-degree angle. So this altitude is going to be green. This altitude is also green. So the way we're setting up this ratio is going to be green over green is going to be equal to, well, one set of those corresponding sides. Here I'm going to choose to use AC, and AC would correspond to FH. Just looking at this visually and then also looking at the similarity statement, we can verify that. So the way that we're going to write our ratios here is green over green is equal to yellow over yellow. So if we fill that in here, what we're looking at then is AD over FJ is equal to yellow over yellow would be AC over HF. And that's really all it is. It's kind of similar to when we're looking at setting up proportional sides. The corresponding altitudes in this case can be set up as a proportion with the corresponding sides. And so we'll look at angle bisectors. We're pretty much saying the same exact thing here. So if I have two similar triangles, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So we're looking at the same concept here. Here's my angle bisector. We know that that's an angle bisector because it's cutting angle R in half into two congruent pieces. So this would be the angle bisector LP for the second triangle. So what we're saying here then is because these triangles are similar, I can set up a ratio of the corresponding altitudes would be equal to one pair of corresponding sides in the two triangles. So for this one, we can pick QR and KL, but I could also pick any of those other sides of the triangle. It really doesn't matter. So I'm looking at here, green over green is equal to yellow over yellow. So if I fill that in here, I'm looking at RT over LP would be equal to QR over KL. Right, and so that's going to be how we're setting up the ratios. And we have to understand that you can set up ratios different, just make sure you're being consistent. So what I mean by that is you could have also set this up as yellow over green is equal to yellow over green. As long as you're consistent, it's not going to make a difference when cross multiplying. Okay, but we'll move on here. Let's look at medians. Medians, remember that medians start from a vertex and go to the opposite side and hit that opposite side's midpoint. So it's going to create two segments that are congruent here. Well, we're saying pretty much the same thing as we said with angle bisectors and with what we said about altitudes earlier. We're saying that if we have similar triangles, then the corresponding altitudes, in this case CD over YZ, I said altitudes, I meant medians, sorry, but the corresponding medians here are going to be proportional to the one pair of those corresponding sides. Okay, well technically all of the pairs of the corresponding sides, but I only need one to set up a proportion. So for this one, let's pick something different. Let's pick BC. Okay, BC, if you want to double check, BC corresponds to XY. So corresponds to XY. So if I set up my ratio here, I'm looking at green over green is equal to yellow over yellow. When I fill that in here, I'm looking at CD over YZ is equal to yellow over yellow would be BC over XY. Okay, and that would be how we set up our proportions, and we would cross multiply. So what we'll look at now is some examples of these different kind of situations here and kind of see how this works out whenever we have actual numbers to work with. So for example 1, it says in the figure, triangle ABC is similar to triangle FDG. Find the value of X. Well, I'm seeing here that I have a special type of segment here the fact that these little angles are marked congruent tells me that this is an angle bisector. So the angle bisector in the first triangle will correspond to the angle bisector in the second triangle. So we're setting up our fractions pretty much the exact same way. Here's my two fractions. To set up my proportion, what we're going to do here is what we did earlier. Green over green is going to be equal to yellow over yellow. So we have to pick our set of corresponding sides. I'm going to have to pick the one that has 15, AB. So AB corresponds to the first two letters in the second triangle, which is FD. So I can now set up my proportion. If I'm setting this up here, what I'm looking at is my green over green is going to be AP, which is X, over 8. And then yellow over yellow would be 15 over 12. From here, we're going to go ahead and cross multiply. If I cross multiply here, 12 times X gives me 12X. And then 8 times 15, that gives us 120. If we divide both sides by 12, we end up seeing that X is equal to 10. So they asked us find the value of X. We've found the value of X. It's X is equal to 10. Okay, and you'll realize that pretty much every single problem that we're looking at for today's notes, if it's a median, if it's an angle bisector, if it's an altitude, they're more or less set up pretty much the exact same way. So we'll run through these pretty quickly. Example 2, it says find the value of X. What I do kind of want to practice here is just identifying the type of segment we're working with. Here I see that I'm working with this segment highlighted in green, and it's creating a 90-degree angle. This would be identified as an altitude. So this altitude MP would correspond to the altitude in the second triangle YQ. So that'd be my green over green is equal to, now I got to pick my yellow over yellow. Well, I'm going to have to pick the side with 20. That's KM. And so here, they don't necessarily give us the similarity statement, but I see that KM connects the angle that has a single curved line and then the unmarked angle. So that would correspond to the single curved line here and the unmarked angle, so that'd be going with 15. I know for this particular problem, it's pretty obvious, but in certain situations, you will have to pay attention to details so that you don't set it up incorrectly. But we got our green over green, yellow over yellow. Let's go ahead and plug those values in. If I do green over green, I'm looking at 16 over X. That's equal to yellow over yellow would be 20 over 15. Then we cross multiply. So if I cross multiply here, 20 times X is 20X. If I multiply the other diagonal and I look at 15 times 16, 15 times 16 gives us 240. Okay. So my next step would be to divide by 20. We end up seeing that X is going to be equal to 12. Okay, and we're done. They just asked us to find the value of X. We found it. Okay, example 3. We're looking at more or less the same thing. For this one, I'm just going to go ahead and set it up. If I'm looking here, the special segment I see drawn in the picture is PT. PT is going to represent a median. Okay, and we should have been doing this earlier. We'll go ahead and write these into our notes. Okay, for example 3, I was looking at medians. Example 2, that special segment in green. Let me scroll back down to example 2. That segment in green, MP and YQ, those are altitudes. And then what we looked at in the beginning were angle bisectors. Right, so just us practicing identifying the special segments. So if I'm working with medians, it's going to work pretty much the same way we've been setting up the other ones. I'm looking at green over green is equal to yellow over yellow. Okay, so if I look at this, we end up seeing that, well, they don't give me the length of an entire side here. Okay, and so what they do give me is this little piece here. Okay, this little piece SP. Okay, well, that little piece would correspond to side UQ. Okay, now normally I would have to do this with the entire side, okay? And if you're unsure whether you can do this with just that half that we had, so what I'm saying is if you're unsure that we could set this ratio up with X over 3, then just look at the whole thing. This would be a good way to kind of practice. If this is X, then this is X. That would make this entire side 2X. And then similarly over here, UV, if UQ is 3, then this is 3. That would make this whole side 6. Okay, so if I set up my ratios here, I'm looking at green over green is equal to yellow over yellow. okay? So if we set this up, then green over green, we're looking at 13.5 over 9 is equal to yellow over yellow would be 2x over 6. And then from here, we just cross multiply. If we cross multiply, what I'm looking at here is 2x times 9. That would give us 18x. And then the other diagonal, 13.5 times 6. If we put that in the calculator, we can see that that gives us 81. From here, we just divide by 18. If I divide both sides by 18, we end up seeing that x is equal to 4.5. Okay, and so we ended up getting a decimal for this one. That's okay, that happens. Okay, so don't freak out or start to doubt yourself if you get a decimal, unless it's something like a really long, crazy decimal, then you might want to double check your work. Okay, but for now, we'll keep it moving here. What we're going to look at here is the triangle angle bisector theorem. This is pretty much kind of more or less stating something similar that we've already looked at with angle bisectors. So the triangle angle bisector theorem states that if an angle bisector in a triangle separates the opposite sides into two segments. So for context here, here is our angle bisector here in green. What it's saying is if it separates the opposite side, which is KL, into two segments, here is the two segments KL and ML, then what's going to end up happening is that that separated set of sides is going to be proportional to the lengths of the other sides. Okay, so in other words, what we're saying here is that when I got that green angle bisector, you're going to be able to create the following proportion. We can end up creating this setup as yellow over yellow is equal to blue over blue. Or, I mean, it just depends on how you want to do it. You just have to be consistent is all. So, and I'll show you guys both ways that you could potentially set this up. We can do yellow over yellow is equal to blue over blue. So if I do yellow over yellow, I'm looking at Km over ML is equal to JK over JL. Okay, so that's us setting it up as yellow over yellow is equal to blue over blue. Okay, what I can also do though is we could also set this up as having our yellows on top and the blues on the bottom. So in other words, yellow over blue is equal to yellow over blue. So what that would look like is Km over the blue section there would be JK. That's equal to ML over JL. Okay, you could set it up either way. Just make sure that once you set up that first ratio that you make the second one consistent and you make it be set up in a similar fashion. So with that being said, we'll jump into example 4. It says use the triangle angle bisector theorem to set up a proportion and solve for x. If I look at what we currently have here, we'll go ahead and just rely on the highlighters here to kind of help us make sense of this situation. So it says fill in the blanks. QT is this part right here. And then QR is this part right here. Okay. So what it looks like we're doing is kind of the first setup that we ended up doing right here, where we had yellow over yellow is equal to blue over blue. So let's set it up that same exact way. So my yellow over yellow here would be QT over TS. And then my blue over blue would be QR, which we already have, over SR. Okay, and so we'll end up setting this up. This was my blue over blue, and then here was my yellow over yellow. Okay, so they're pretty much kind of helping us set this up. We're setting this up as yellow over yellow is equal to blue over blue. So if I plug this in here, okay, what we end up seeing here is that on the bottom piece here, what I'm missing here is TS. Well, TS, I currently don't know what it is. It's this part here in red, but I know that the whole thing is 18. Okay, so if the whole thing is 18, then, sorry, if this whole thing here is 18, the Q to S is 18, and I want to just find the red segment, then I need to subtract out that yellow piece of X. So what this is going to end up becoming is this is going to become 18 minus X. So here we end up with 18 minus X. And then my part here in blue on the bottom, what I'm asked to write here is SR. SR, they told us, is 14. So there's our setup, okay? If we're going to go ahead and solve for x here, we need to cross multiply. So if we cross multiply here, if I multiply this diagonal, we get 14 times x. And I'm going to kind of show more steps here because we're going to have to distribute. If I multiply the other diagonal, this is going to be 6 times 18 minus x. Okay, so from here we multiply it out. 14 times x here gives us 14x. So we got 108 minus 6 times x is 6x. We added 6x at this step here. We ended up with 20x is equal to 108. I would divide by 20, and if we divide 108 by 20, we end up with x is equal to 5.4. Okay, there was no rounding here. X is exactly equal to 5.4. Okay, so for these particular answers, you could leave it as a fraction or you could leave it as a decimal. Okay, either or. But again, just kind of reiterating that if you end up with a decimal, that's okay. Sometimes that happens. Okay, we got a few more examples to kind of go through here, and then we'll finish up the notes here. So for example 5, it says in the figure below, WYZ is similar to ACD. So if XZ is an angle bisector, here, then what ends up happening here is that if these guys are similar, that would imply that BD is an angle bisector as well. Okay. So if these are similar, at least. But for right now, for this section, we're just talking about XZ. So we're just going to be focusing on this triangle right here. Okay. So we mentioned that if we have an angle bisector, it's going to create some proportional pieces here, right? So this will be my yellow over yellow. And then here we'll have our blue pieces here as WZ and YZ. Okay. If we take a look at how they set this up, the way that they set this up was WX, which is our yellow right here. And then XY happens to be our other yellow. So they're setting this up as yellow over yellow. This is going to end up being equal to blue over blue. So if we fill this out, we're looking at WZ over YZ as the missing piece of information here. So we'll move on to part B here. It says if XZ is an angle bisector, WZ is equal to x plus 3. They're giving us a bit of information here, so it might be worth going ahead and labeling our triangle. So WZ is x plus 3, so this guy here, x plus 3. WX is 4. XY is 6. And YZ is 12. Okay, so they gave us a picture to kind of go off of this, so it would make sense for us to use it. If I'm going to look at setting up my fractions here, just take a look at yellow over yellow. Yellow over yellow is going to be 4 over 6. That would be equal to blue over blue would be x plus 3 over 12. From here, if they're asking us what is the value of x, what we have to do is we got to cross multiply. Okay, so this would be 4 times 12 is equal to 6 times x plus 3. From here, when we work it out, 4 times 12 gives us 48. That's equal to 6 times x is 6x, and 6 times 3 is 18, so plus 18. From here, we would subtract 18 on both sides, and we'd see that 48 minus 18 gives us 30, so 30 is equal to 6x. Last step here, divide both sides by 6. We get that x is equal to 30 divided by 6 gives us 5. So x is equal to 5. Okay, so again, the highlighters are there to kind of help us get a better understanding of how to set these problems up. By now, we should be comfortable cross multiplying. So these examples are pretty similar to kind of what we've already seen. We'll go ahead and skip example 6. Let's look at example 7, okay? Because I do want to practice the ones that kind of require us to do a little bit more work first. So if example 7 has this segment here drawn in, okay, what this is an angle bisector because it's cutting that top angle in half. So if that's an angle bisector, we said that it splits it up into our pieces here that are proportional. Here are my yellows, and then here are our blues. Okay, what we don't immediately know is this first yellow here that I have in red, but I can find it because the total length of that bottom side is 20. If I subtract out this yellow piece right here, then this would be 20 minus x. So from here, now we can go ahead and set up our proportion. Okay, we'll set this up in the way of yellow over yellow is going to be equal to blue over blue. So if we set this up, my yellow over yellow is going to end up being 20 minus x over x. My blue over blue is going to be equal to 11 over 14. Okay, so we'll cross multiply real quick. This is going to be 14 times 20 minus x, and that's equal to x times 11, or 11 times x. And then we just work it out. If we end up multiplying this out here, what we're starting with is 14 times 20. If we multiply that out, we get 280. And then 14 times negative x would give us negative 14x. And that's equal to 11x. From here, we'd add 14x on both sides. If we do that, we end up with 280 is equal to 25x. Last step here is divide both sides by 25. 280 divided by 25 gives us an x value of 11.2. Okay, so we found the value of x, it's 11.2. Okay, we got a few more examples here down at the bottom, and if we look at example 8, we'll just go through the setup. We're not going to go ahead and take it and solve it all the way. We've done enough solving here to where hopefully you guys feel comfortable. It says triangle KYC is similar to triangle BLH, find x. What I see here is this special segment is touching this side right here at its midpoint, so that's a median. Okay, so that green segment's a median. That means it's going to correspond to this median in the second triangle. And if I'm going to set this up as a proportion, okay, I need it to correspond to another side. So I'm going to use the 2x minus 9, which is YC. So it corresponds to LH. So those two go together. So I'm going to just set up my ratio here then as green over green would be 20 over 12 is equal to yellow over yellow would be 2x minus 9 over x minus 2. And from there you would cross multiply and solve for x. If you want to pause the video and try cross multiplying and solving on your own, I'll put the answer up here shortly. So again, if you want to try this one, pause the video. Okay, so by now, if you solved it, if you wanted to check your answer, what you should have gotten is x is equal to 17. Okay, and we'll finish up with this last one here. This last one here, what I see is I have a special segment, but it's occurring on the outside here. And again, remember, if I start from a vertex and connect it to the opposite side and it creates a 90-degree angle, what I'm looking at here is an example of an altitude. Okay, so that segment there in green is an altitude. So it's going to correspond to the other altitude here in the second triangle, because they did start off by telling us triangle PQR is similar to triangle UTS. So again, we're going to pretty much do what we've been doing the entire set of notes. We'll do green over green is equal to yellow over yellow. This is the only other side length that I'm given in the first triangle, which is given by PQ, the first two letters. So that corresponds to UT. So it corresponds to this side. So if I'm going to set this up, green over green would be 12 over 15 is equal to yellow over yellow would be x over 42. Okay. If you cross multiply, this one's not that bad. We'll just go ahead and work it out real quick. 15 times x is 15x. And then 12 times 42 gives us 504. From here, you would divide by 15. We end up with x is equal to 33.6. Okay. So that's going to cover the end of